With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Everyone, today's our question is two intersecting lines lying in plane P1 have equations x minus 1 by 1 is equals to y minus 3 by 2 equals to z minus 4 by 3 and x minus 1 by 2 equals to y minus 3 by 3 equals to z minus 4 by 1. Okay, if the equation of plane P2 is 7x minus 5y plus z minus 6 equals to 0, then the distance between planes P1 and P2 is. So in this question they are given us two intersecting lines which are this, and they lie on a plane. We have a plane P1, okay, and in this plane these two lines are intersecting. Okay, so we have to find out the distance between planes P1 and P2. So for first we will find out the equation of plane P2 with the help of these two intersecting lines. So for first what we will do, we will write the given two lines, which is we have first line is x minus 1 by 1 equals to y minus 3 by 2 equals to z minus 4 by 3, and second line is we have x minus 1 by 2 equals to y minus 3 by 3 equals to z minus 4 by 1. So here we have two intersecting lines. Now what we will do that, so here we can see here that here this is 1 3 4 and 1 3 4 are common in these two lines. So we can say that here these 1 3 4 are the intersecting point. Okay, so we can say that 1 3 4 is the intersecting point, on a plane on which they are intersecting at a point. Okay, so we can say that at 1 3 4 these two lines are intersecting. Okay, so now we have a first we will find out the equation of plane P1. So we can say that we have a formula for equation of plane. We have normal vector. So for this first we will find out the normal vector for finding the equation of plane, normal vector and a point in plane. So here we will find out the point in plane over here, and now we will find out the normal vector also. Okay, so this is the intersecting point which is point in plane. Now we will find out the normal vector first, then we will find out the equation of plane through this. So now what we will do that, we have two lines, okay, and they are we can say that in denominator this is 1 2 3, this is 2 3 1. So 1 2 3 are the direction ratio of this line, and similarly 2 3 1 are the direction ratio of this another line. So now we have if we write the direction ratio in the form of equation vector form, so we have r1 vector. R1 is the direction ratio of first line. R1 vector we have, this is 1 into I cap, then we have plus this is 2 j cap, then we have plus this is 3 k cap. So we can say that this is the direction ratio vector of this first line. Now we have, and similarly another line which is r2. So r2 vector which is 2 I cap, this is equals to 2 I cap plus 3 j cap plus k cap. So here we have the two direction ratio vector. So now for finding the normal vector, we will first do the cross multiply of this r1 and r2 vector. So for this we have r1 vector cross r2 vector. So by cross product we will write it as determinant of I cap, j cap, k cap. Then we have r1, this 1 2 3, r2 is 2 3 1. So this is 2 3 1. So by solving this, we will write it as this is first I cap 2 into 1 is 2, 2 minus 9, so 2 minus 9, then we have minus j cap, so minus j cap, this is 1 minus 6, then we have plus k cap, so k cap 3 minus 4, so we have 3 minus 4. So we can say that this is equals to, this is equal to minus 7 I cap, then we have minus plus 5 j cap then we can say that we have minus k cap. So this is the value of r1 cross r2 vector. So now what we will do that? Let us suppose this is cross product, so we can say that this is a normal vector. So now we can say that this is the normal vector. So here we can also find out the normal vector, which is this, and we have intersecting point this. So now let us suppose we have a general point. Let a general point which is x comma y comma z in the plane P1. In the plane P1 we have a point. Let us suppose this is x comma y comma z. So now if we write the distance from this point to this point, then we can say that, let us suppose this vector in the form of vector. So we have a vector which is equal to distance from this point to this point is, we can say that in the form of, this is x minus 1 I cap, then we have this is y minus 3 plus y minus 3 j cap, then we have plus z minus 4. So the z minus 4 k cap. So this is a general vector in a plane. So we can say that this is general vector. This is general vector in a plane, which is a capital A vector. So now what we will do that? Now for finding the equation of plane, we know that normal vector is perpendicular to this point in plane. So we can say that we have a, so we know that if normal vector, this is a normal vector, so we can say that this normal vector is perpendicular to this plane. Okay, so we can say that a vector dot n vector, which is equal to 0, and we also know that the dot product of perpendicular vectors is equal to 0. So we can say that here we have a vector, capital vector is this, and n normal vector is this. So if we do the dot product, okay, so if we do the dot product of these two vectors, so we have, first is x minus 1. So x minus 1 into coefficient of I cap, x minus 1 into minus 7, then we have plus y minus 3. So y minus 3 into 5, then we have minus 1 z minus 4. This is equal to 0. So we do the dot product of this with this. So here we will write it as this. So now what we will do that, by solving it, we will write it as, this is minus 7x. So minus 7x minus plus 7. This is plus 5y plus 15. This is minus z minus plus 4. This is equal to 0. So we will write it as minus 7x plus 5y minus z. This is 7 plus 11, 15. So we can say that here we have this is my y minus 3, sorry, this is y minus 3. So this is minus 15. So this is minus 15. Sorry friend, this is y minus 3. So this is minus 15. So we have minus 4. Okay, so we can say that here we have minus 4, which is equal to 0. So if we take minus common over here, so we have 7x minus 5y plus z plus 4. This is equal to 0. So this is the equation of plane P1. So we can say that this is equation of P1 plane. So here we can say that here we have, now we will find out the equation of plane P1, and they are also given as the equation of plane P2, which is 7x minus 5y plus z minus 6 equal to 0. So we write it as P1 is we have 7x minus 5y plus z plus 4 equal to 0. Similarly, P2 is 7x minus 5y plus z minus 6. This is equal to 0. So now here we can see that the coefficient of x, y, z in both the planes are same. So here these coefficients of x, y, z in both the planes are same. So that's why we can say that here P1 is parallel to P2, because here the coefficient of x, y, z in both the equations are same. So that's why we can say that the plane P1 and P2 are parallel to each other. Now we have to find out the distance between P1 and P2. So if we write it distance in, so if we write this plane, so let us suppose we have a plane, we have two planes, one in the form of ax plus by plus cz plus d1. Similarly, we have another is ax plus by plus cz plus d2, which is equal to 0. So from here we have a distance formula. So distance formula is, which is d equal to mod of d1 minus d2 divided by, we have under root of coefficient of a square under root of a square plus b square plus c square. So this is the direct formula for finding the distance between two planes. So here we have all the values. So now we put here that, so we have d1 minus d2, which is d1 is 4 and d2 is minus 6, so minus minus plus, this is 4 plus 6 divided by under root of a square. A is 7, so a square is 49 plus we have b is minus 5, so b square is 25, so we plus 25 plus c square, c is 1, so this is 1. So we have, this is 10 divided by, we can say that 10 divided by, we have, this is 50 plus root 75, so root 75, and we will write it as, so we will write it as d is equals to 10 divided by, this is 5 root 3, so we have write it as 5 root 3, so we can say that this is cancelled, so we have 2 by root 3. So we can say that distance between P1 and P2 plane is 2 by root 3, and this is our required answer. Thank you for watching. Okay, and our option number B is our correct answer for this given question. Thank you for watching.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.